Do you want to improve your performance of your Spring Boot applications on the cloud? I'm already ready. And today we're going to look at using a native builder to optimize your Spring Boot application running on Azure using a cloud native build pack. So first of all, let's define what a native image is. A native image isn't exactly what you think it is. It's not something that miraculously just appears on your cloud. It's a standalone image that has been executed and hyper optimized with your application code, including the Java virtual machine, your application libraries, and also its runtime components. But it analyzes it to get the best performance out of your application, knowing exactly what your application's about. It uses ahead of time compilation with the GraalVM also to go in and make sure that it doesn't pull classes at runtime to slow down your system. So you go from something that used to take 20 seconds to something that takes sub-milliseconds. In today's demonstration, we're going to be taking the Spring Pet Clinic application and deploying two versions of it. The first version is going to be the standard application, and the Spring application uses an embedded database and uses the Spring framework to capture vets, pets, and also vets visits. The second application, we're going to do the same application, except we're going to give it an opportunity to go in and compile it to a native image. If you want the source code for the entire example that I'm doing today, you can check it out in the link below. So I've gone ahead and already created the resource group, the Azure Spring App instances, the jar app, and also the native app, along with the builders for both. QuickStart link in the link below if you want to get started also on that though. Now, I know what you're waiting for. In the image that I'm showing now is a custom native build pack that I'm using for the Spring Boot native image though. You can see there it uses the Jamstack Tiny and also a custom builder to get those layers hyper optimized for Azure. And then it'll compile all the Java to a standalone executable. Now let's go in and deploy the app then. So I'm going to deploy the Java app and also the standalone app. Now that we've got them deployed, you can see there that the startup time for the standard app is kind of what we expected. 20 seconds, maybe 30 seconds, up to 40 seconds, because it has to go in and find all those classes that it needs to run and execute. Whereas the native build already knows what to expect and is in sub-second milliseconds to start up though. What you'll also see is that I've gone ahead and I've downgraded the native app's memory to 512 megabytes. I tried to do the same with the jar app, wouldn't even start. It said, sorry, your app is in a failed state though. So not only is the startup time way quicker, but we also get way better memory improvements and also processing of requests. So it uses 50% less memory, 10 times faster startup time, and better response time. So today what I've shown you is that you can go ahead and get a native image. It is hyper performant, easy to deploy into Azure. And if you like this, check out the other videos on the series though. We've got quite a lot on Azure Spring Apps, and I look forward to hearing from you around your native image experience and journey on Azure Spring Apps.